In number two, we're looking at tan now. So we were told that the tan theta, or the slope, is 8 over 5. So it's positive 8 over 5. And it's in quadrant 3. Now, this fact that it's in quadrant 3 is very important because although we have to consider two different angles, we have to decide which of the two angles that we get is going to be in the right quadrant. So I'm going to draw in this position. So it's going to be rise over run. So rise over run of 8 and 5 look like this, but it's going to be negative 8, negative 5 because I'm in quadrant 3 here. If I were to kind of extend this out, this would give me the positive 8 over 5 slope. However, it's in the wrong quadrant. Okay, so we're going to focus on quadrant 3. So using my calculator, I'm now going to solve for the angle. So I'm going to do arctan 8 over 5, and that's going to give me theta 1. And theta 1, so second theta, 8 divided by 5, is going to give me 57.99. It's about 58 degrees. So theta 1 works out to be 58.99 degrees. Okay, now, sorry, 57.99. 57.99 degrees. And that happens to be this one here. That's theta 1, 57.99 degrees. Now that is definitely the wrong angle. That's not the one I'm looking for because it's in the wrong quadrant. Now, although it matches a triangle angle, remember that everything is to do with the position angle. So I need to find this position based on that first angle. And theta 2 for tan is going to be 180 degrees plus theta 1, which is 57.99 degrees. Okay, it's going to be on the opposite end of the circle, and we're going to end up in this position down here when we add 180 degrees, and we get 237.99 degrees. Okay, so that's going to be 237.99 degrees is going to get me into quadrant 3. Okay, so if we know the quadrant, although we have to consider two possibilities, possible positions, we have to decide based on the quadrant what the solution is. So again, here, this is now telling us it's in quadrant 2. So that's very important and relevant information. Quadrant 2 means I'm going to be in this quadrant. It's a negative cosine, so negative cosine could be in quadrant 3 as well. Okay, but we don't want to be in that quadrant. So I'm going to draw this in. I have negative 3 along the x, cosine is horizontal, and we have 5 along the y, and this angle here is the angle that I'm looking for. Okay, the positional angle, and solving for theta, I'm going to do the inverse sine. So I'm going to do the inverse cosine, or the arc cosine of negative 3 over 5, and that's going to give me my theta 1. And my theta 1, we'll have to figure out which quadrant it's in, but negative 3 divided by 5 gives me 126.87 degrees. I'm just going to write that down before I forget. 126.87 degrees. Now that angle is in quadrant 2. So that is a correct angle. So the angle from my calculator happens to be the right angle. So I'm done. Just to be complete here though, I'm just going to sketch in that negative 3 over 5 could have been in this quadrant here. Okay, could have been locating that position because the symmetry of cosine is folding along that horizontal line. So we don't want that angle. Theta 2 happens to be, I think it's going to be about 230 13 degrees or something like that. Okay, but again, it's going to be we can find that by starting at 360 and going backwards the theta 1 angle that we found, or 360 minus theta 1. That's the formula for theta 2 when we're talking about the cosine angle. Okay, so but since we are dealing with quadrant 2, we're just going to focus on quadrant 2, and then to find sine and tan. So sine of 126.87 degrees, we have to use Pythagoras to find the third side. 5 squared minus -3 all squared is going to be 25 minus +9, and we get 16, and we square root to get 4. So sine is going to be the vertical over the radius. Tan is going to be slope, sloping in the negative direction, and the slope is -4/3. We could write it as 4/-3 if we like.